Oh, okay, there we go. Okay. Okay, fine. Everyone can see my screen, right? Please let me know in the chat if you cannot see my screen. Okay, cool. I guess we can start this. So today we are going to be covering C++ basics, and this is part 2. And last time we left off at if statements, if conditions, right? So our goal for today is to understand loops. We are going to start off where we left off. So we are going to start with loops, and then we are going to go over arrays. Now, loops and arrays, most problems need loops and arrays. Like 90% of the problems require you to, know about loops and arrays. So they are very, very important, right? So they are extremely important. And after that, we are going to be covering functions. So functions are very useful when you have, when you want to use a reusable piece of code. So we'll be going over functions. And we'll also be talking about ranges of data types. So the range of integer, for example, and range of long, and when to use either one of them, right? Now, after that, we are going to be discussing headers and namespaces. Now, in the last class, we had, like, once again, let me just build the template that we had in the last class, like hello world for hello world program. So we had this thing, right? We had something like this. Now, we are going to be discussing this basic thing, like what is this first line? What is the second line? And what is this thing over here, right? So we're going to be going over all of those. And we are also going to look at some competitive programming tricks. So there are some tricks you can do to make your code faster, and you can save time by doing some things. And we are going to be going over all of them. And I'll show you my template for CP. So I have a basic template. I'll just show you the, oh wait, okay, I have a basic template. So this is my template. I'll go over all of this. Don't worry, by the end of the session, you'll know everything here. And we are going to see how this works, right? So we are going to see what my template is. Okay, fine. Is everyone ready? Can you start then? Please let me know it like a +1 in the chat. Okay, there you go. I guess we can start then. If you have any doubts at any point, please do let me know, by the way. If you have any doubts regarding anything that we have discussed so far, yeah, you can feel free to let me know. Okay, cool. So we are going to be starting with loops. So first of all, loops are used to repeat a block of code, right? Like you can tell from the name. What is a loop? A loop is something that keeps going around and around, right? So a loop is just something that keeps going around and around. So first of all, that's what it does. It just repeats a block of code. So if you have some code, then it is called a block of code. Like anything that you have inside a scope technically is called a block of code. Like for example, if I type something here, int A, int B, something like this, I just type something random, right? Then this is called a block of code, right? So this is going to repeat a block of code until some condition is satisfied. Now, I'll explain what all of this is. But first of all, there are 3 types of loops in C++. There's the for loop, there's the while loop, and then there's the do while loop. So the do while loop is very rarely used. It's extremely rare. For loop is most commonly used. And while loops are a bit uncommon, but they're still used. So we are not going to be discussing do while loops, but their while loop and do while loop are very similar. Like I leave it as a challenge for you to try Googling this and understanding do while loops, right? It's very similar. Like, don't worry about it. Like, it's extremely similar and you don't need to know it in fact, but bonus points if you Google it and try and figure it out. Okay. Now, let us discuss some points. Let's discuss some points first. First of all, an iteration. There is something called an iteration. An iteration is a very important word when you're doing looping and stuff. So an iteration is basically one time the loop gets executed. It's literally just one time the loop gets executed. And for example, if you take the third iteration, then it is the third time the loop is run, right? So let us say that something happens. You have something that happens 5 times, right? Let's say something happens 5 times. Then this is the first iteration. This is the second iteration. This is the third iteration, and so on. Right. So the first time it happens, it's the first iteration. The second time it happens, it's second iteration, right? So yeah, that's basically all there is to an iteration. And then we'll also discuss what break statement and continue statements are. Okay, cool. So first of all, let's start with the for loop. So the syntax for a for loop is actually extremely simple. So for the syntax of a for loop, all you have to do is type for, right? All you have to do is type for. Then you have one statement, the second statement, and then the third statement. We'll go over what all of this means. But after that, you have a curly brace. And whatever you type inside this curly brace, whatever I type here, this is the part that's going to get repeated, right? So this part is going to get repeated until the some condition is satisfied. Okay, so we have three statements here, and the statement one is executed once, exactly once before the start of the loop. So what this means is that if you have some statement here, for example, let's say I say int I equal to 0, this is going to get executed exactly once, right? So this part over here, this is going to get executed exactly once. So this will only get executed once before the loop starts, Okay, so that is the first statement. So if I say int I equal to 0, that's executed once before the loop starts. Then the second condition, okay, what happens here? Okay, so the second condition is the condition of the loop. Like the second statement is a condition of the loop, and this loop stops if the condition is false. Okay, Arun Kumar says initialization, condition, termination. That's exactly right. Actually, no. The third one is not termination. The middle one is termination. The third one is increase, right? Okay, I'll come to that, but I think that's a bit wrong, Arun Kumar. Okay, so the second condition is the second statement is a condition of the loop. And what happens here is if you have a condition, like let's say I less than 10, then what this means is that this code will keep repeating. This code will keep repeating until this statement is false. So for int I equal to 0, this statement is true. If you have I equal to 7, this statement is true. So it will keep continuing, right? But it will stop whenever this condition is false. Jignesh says, are all S1, S2, and S3 mandatory? I will come to that. They are not mandatory actually, but I will tell you like the specific process that you need. I will let you know in a while. Okay. So this is for int I equal to 0, I less than 10, which means that this will keep repeating until I less than 10. Now, statement 3 is executed after each iteration, which means that it's executed once after each iteration, meaning that if I do something like I++ here, this will increase by 1 after each iteration, right? It will increase by 1 after each iteration. Okay. Now, let me show you how this works. Okay, 1 second. Yeah. Okay, so we have let's say we just have an iteration, right? I will represent an iteration with a rectangle like this. So before we start, we have int I equal to 0. We are creating int I equal to 0 before the loop starts. Then after that, I'm saying that is I less than 10? Is I less than 10? If yes, continue, otherwise stop, right? So if yes, I'll keep continuing. Otherwise, I'll exit out of this loop. Right? So if I less than 10, I will continue. Otherwise, I'll stop. Now, if I is less than 10, I will go inside this loop. Okay, I'll go inside this loop, which means that, 1 second. I'll go inside this loop, which means that I'll be doing what the loop has. So I'll be doing whatever is happening in this loop. So I'll perform whatever is in this loop. And then I will say I++, right? So the final statement is executed. So the statement 3 is executed after the things inside the code is done. So if this condition is true, I go inside. And then after I do everything inside this, I will do I++. Okay. Now, after this is done, what I'll do next is, well, if this condition is true again, I'll keep repeating. So this statement will keep repeating until this condition is false. Okay. Let's actually say that we are taking I less than 5 over here, right? Let's say I'm taking I less than 5 over here. I'll just replace this. Okay. At the beginning, I equal to 0. Now, this I less than 5 is obviously true, right? So 0 is less than 5 is obviously true. So this statement will, this iteration will happen and I++ will happen. Now, I will be equal to 1 on the second iteration. At the beginning, I is equal to 0. Here, I is equal to 1, right? And this is also true. So this will continue. Now, here, I is equal to 1. Now, it will become I is equal to 2. And then it's true. Then it will become I equal to 3. And it's true. And after that, this will happen again for I equal to 4. And that's also true, right? But then finally, we have I equal to 5. Now, will this statement happen? Okay, this actually should be 5. Will this final loop repeat? Okay, Jignesh says S1 is the starting position, but why at 0th position? I can take any value that I want, actually. I can take whatever value I want. Here, if I say I equal to 3, for example, I'll start with 3, right? I just took 0 as like a random thing. Okay, as everyone is saying, we will not go through the 5th iteration. We'll not be going through the fifth iteration. And the reason is pretty simple. We have I less than 5, which is false, right? 5 less than 5 is false. So we immediately stop. None of this will happen, right? So after I equal to 5, I will be stopping. Okay. So let's actually try looking at this in code here. Let's just say that I output I over here, right? Let's just say I output I over here, and let me run this. You can see that first I start with 0, then I go to 1, 2, 3, and 4, and that is correct. And when you are at 5, we immediately stop, right? We immediately stop because I less than 5 is again not true. So if it's not true, we will stop, right? So this is the loop. The loop is done. Okay. Now, like Jignesh asked, actually, how can we remove, is all of this mandatory? Do we need all the statements? Well, not all the statements are actually mandatory. For example, I can remove the first statement. I don't need the semicolon, right? I need the semicolon for sure, but I can remove the statement. And then I can say outside int I equal to 0, right? This will also work completely fine. Now, one advantage of doing this, if I had this inside, what the issue is that I cannot do cout I or anything like that. So if I do cout I here, you can see this is an error. But if I put this outside like this, then I remove this, you can see that I can still output I, right? After this loop ends, I can still output I. But yeah, you can remove the statement, but you still need the semicolon. So I can also remove the last one, and then I can do I plus plus inside. That's also totally fine. And I can also, do if I less than 5, we can break. Now, this brings me to the break statement. So the break statement is basically when if a condition is false, okay, if not I less than 5. So if the statement is false, I need to break, right? So if the statement is false, I'll say that break. Jignesh, what do you mean by PT? Sorry, starting PT. Oh, starting point. Okay. Yeah, we can take the starting point as whatever we want, but we need a starting point, right? Like, where do we start? Otherwise, we don't know where to start, right? Like, if I can start wherever I want. For example, I can start at 3, but I do need to have a starting point. Can I explain the semicolon in the loop again? Yeah, sure. So this is statement 1, this is statement 2, and this is statement 3, right? I am supposed to have a statement here, but I can also remove the statement and it will still work fine. So that is basically what that is. Arun Kumar says, because I is global variable, that's why it's not showing error. Yes, exactly. So since it's outside, well, it's not showing an error because it is in the same scope. But yeah, so here we can replace this again. We can take int I equal to 3 inside this for loop. We can take int I equal to 3 inside this for loop. Then I can say I less than 5, right? I can say I less than 5 inside the second statement. So this will repeat until I less than 5. And in the third statement, I can do I plus plus and remove that outside. So this is the same thing, right? Okay, Jignesh says, if you declare I in loop, why was the cout giving an error? I don't understand. Okay, so the issue was that if I output it here, the thing is, when I create it inside the for loop, this is only inside the for loop. So all of this is happening. 1 second. You can imagine all of this as happening inside the for loop, right? Everything here is happening inside the for loop, including the initialization. So this is the entire for loop. But let us say that I want to use this I value outside. I want to use this I value outside. But that won't be possible, right? Because it is inside the scope. It is inside the scope, which I cannot use outside. So what I can do is manually say that this will go outside, right? I can do something like this and now it will work fine. Because I explicitly said that, well, just move this thing over here outside like this. Does it make sense now? This is clear to everyone. Is this clear to everyone? Any doubts here?
Sir, what would happen if we choose plus plus I over I plus plus?
Nothing would change. Absolutely nothing would change because they are basically the same thing. So this will be the same thing, exact same thing. Okay, Jignesh says cout needs to be in or outside the loop. So the cout inside the loop will work fine. So if I'm doing cout inside the loop, this cout works fine, right? But if I do cout outside, like if I do cout I outside, this will be an error. Like this is an error here. This is not an error, right? Over here, this is not an error. But this over here is an error. Okay. Let's say that we also have another variable. You can create another variable by taking j equal to 0, right? Something like this. Now, if I see out j, see, this will also not output. Maybe this is a bit clear now that I use multiple variables. So, yeah. Okay, if this is clear, please let me know it like a +1 or -1 in the chat. If you have any doubts at all, please do let me know. Once you removed all the elements of for, how? So basically, I just see, as long as you have 2 semicolons, this entire thing is valid, right? If you have 2 semicolons, this is valid. Now I had 3 statements. The initial statement, which I'll do outside. The second statement, which was checking the condition, right? So what I'll say is I'll check the condition inside. I can do an if statement. If this condition is false, then I'll say break. Break means that the loop will stop, right? And similarly, I will take ++i inside. So I'll do ++i inside, and all of this has been replaced, right? This is the same thing. This is the same for loop. This is just going to repeat until this statement is true. Okay, Akash says how the j would work. Okay, that's actually pretty simple. If you create variables outside, you can do j I equal to 3, j equal to 5, x equal to 7 or something like this, right? You can do the same thing inside the for loop. So the same thing inside the for loop completely works fine. And similarly, yes, like Ray is asking, we can do the exact same thing with the conditions. I can say that if I not equal to 3 or I less than 5 and j less than 4 and or something like this, like let's say just j is less than 10 and let's say x is less than 13, right? I can do multiple conditions like this with ampersand. And we can also take I++ and I can do j plus equal to 2, like with comma. Over here, I need to use a comma. So I'll do I++, j plus equal to 2 and k equal to like k equal to k into 3 or something like that. Anything random.
Sir, taking multiple conditions and doing multiple sorts of option aren't going to make array. I mean, it's not going to generate an error. Like, how many times will loop run?
So basically, as long as a loop is not infinite, it won't be any error. Like if you loop somehow, you loop forever, then it will be an issue, right? Like let's say you have I equal to 3, I less than 5, and I minus minus. Then this condition is never going to be true, right? That's called an infinite loop. So if a loop is infinite, then you will, you will get an error at some point, but otherwise you will be completely fine. You can use multiple statements. You can do whatever you want. Okay, Jignesh says I++ is to increment by 1. Can you increment by 2, 3, 4 or something? Yes, we can do that. As I'm showing here, you can take j plus equal to 2. This also works completely fine. I can also take k into equal to 3. X equal to x into 3. I can also do this. I can also take x into equal to 3. Anything works. Like you can do a lot of different things. Okay, cool. Is this clear? Please let me know again. Sorry, if you have already understood everything, then it's fine. But if you don't understand, please let me know. And if you have understood something new, then please let me know it like +1. How many variables are allowed? As many as you want. Okay, fine. Decrement will be minus equal to. Yes, decrement will be minus equal to. So you can do minus minus to decrease by 1. Minus equal to will decrease by 2 or something like that. And you can also take slash equal to, which will divide, and you can do whatever you want, basically. It's completely up to you. Okay, cool. So I guess the next thing that we'll be discussing is the while loop, right? So the next thing we'll discuss is the while loop, and the while loop is pretty simple. Okay, somehow this got okay, there was supposed to be a condition here. Okay, so in a while loop, again, you can see that this while, there is some condition and there's a curly brace. Now this is like a verse version. Okay, it's not a verse version exactly, but it's a primitive version of the for loop actually. So if you take while condition, let's say you have while I less than 5, I can have int I equal to 0 outside, and then I take I++, and inside I see out I, right? So what I'm doing is saying int I equal to 0, and while I less than 5, see out I and I++, right? So if I run this, you can see that this outputs the exact same thing. Now this is basically the same as a for loop, except I'm doing, if in a for loop, I'll do something like this, right? In a for loop, I'll do something like this. These two do the exact same thing. I'm doing int I equal to 0, I less than 5, I plus plus, right? And again, we can remove, in fact, a condition. We can remove this condition, like put it outside like this. We can say I less than 5 can be inside, and I plus plus can happen at the end, right? So this is also a while loop. So this part over here, this and this are basically the same thing. So I can do the while loop just like this, right? So while loop is very similar, except you only have the condition. Everything else you have to manage by yourself. Okay, Jignesh says significance of break in loop. Okay, let us discuss the significance of break in loop, right? But yeah, if the while loop is not clear, please let me know, by the way. It's extremely simple though. It's just a condition. Instead of multiple statements, you only have the condition. So yeah. Okay, cool. So let me discuss the break statement. Let us say that I have a for loop again, and I have something like this. And let us say that I want to stop if I is I is divisible by both 3 and 15. 3 and 5, I want to stop, right? So if I modulo 3 is equal to 0, I'm taking the remainder by 3, and then I'm saying if it is equal to 0, which means that it is divisible, right? So if you divide something by 3 and the remainder comes out to be 0, that means that it was perfectly divisible. And let us say I modulo 5 is equal to 0. Then I want to stop this loop immediately. In this case, I can use a break statement. I can say break, and this will immediately stop in the innermost loop. So if I have multiple loops, if I won't be discussing nested loops in too much detail, but let's say that we have something like this. We have two loops like this. If I am breaking inside, then it's only going to break from the outermost loop. It won't break the inner, it will only break from the innermost loop. It will only breaks here, right? So if I want to break here, it will come outside, come out to here. It won't come here. So that's a very important thing. Whenever you break, it only breaks from the innermost thing, right? Okay. And the next thing that we have is the continue statement. So the continue statement is also pretty simple. Here we are breaking. Okay, let me output this. Let me see out I each time. Let's see what this does, right? So this will have to output until 15, right? At 15, it will stop. It will output 15. Okay, what? Oh, okay, we are starting at 0. So the issue is when I take 0, 0 is divisible by both 3 and 5, right? So I'll start at 1. And you can see that it stops at 15, right? Which is what we expected. So whenever it reaches 15, it outputs 15 and then it immediately stops. Okay, now let us say that I just don't want to output 15. I don't want to output 30. I don't want to output 45, etc. But I'm fine with outputting any other number, right? I just don't want to output that particular number. So, okay, first of all, let me put this up here. If I run this, you'll see that it stops at 14. And the reason is pretty simple. Here, it breaks, and then it will try to print, right? But before we print first, and then we print. So whenever we reach 15, here it immediately breaks. Here it prints, and then it breaks. That's why it's outputting only till 14 now. Now here, instead of break, let's say that I do continue. Right. Let's say I do continue. Now what happens is that when I do continue, it will immediately go to the end of the loop. It will immediately skip everything, anything, no exceptions. No matter what I have, it will skip everything and it will go to the end. So if I run this, you'll see that it doesn't output 15. Notice that it goes to 14 and then the next thing is 16. Similarly, I have 29 and then I have 31. And after that, I have 44 and then 46, right? So this is the continue statement. Is this clear? Is this clear to everyone? And similar to a break statement, like the continue statement only happens for the innermost loop. It does not affect anything outside. Okay, I'll just wait for a minute. If anyone has any doubts, please do let me know. And if you do understand, please let me know. It's like a +1 or -1 in the chat.
Hello.
Yeah, hello. Your voice is actually very low, Jignesh.
Okay, then I'll use the chat box.
Yeah, okay.
Are you
Actually,
able
it's
to
better
hear?
now. Yeah,
Yes.
it's better now.
So I am just confused at that what point it would break. Now this is indented. So you told that the next it will at the next step it will break. So the second loop is continued.
Yeah. So
And
this if statement continues.
yes, so if you don't use the continue or break, then what will happen?
It'll print everything. So if I don't have these conditions, it will not print anything. I mean, sorry, it will print everything. I mean, it'll print everything. It will include 15 and stuff. Okay. If I go here, you can see that it prints 15, right?
So we can play in the nested loops using that break and continue syntax only.
Yes, we can do that. Okay, I will show that. But yeah, here you can say, first of all, it's 15. Now, if I comment this out, there will be no 15 because at 15, I'm saying that skip, right? Since this is 15, I'll say immediately skip. Okay. Now, Arun Kumar is asking, what's the basic difference between break and continue? So you can see that here in continue, 14, after 14, we are going to 16, right? If I do break, then notice that it will stop at 14. There is nothing after 14, it stops, it immediately stops. If the condition is true, it stops, right? So it's like saying the loop is over. Okay, Shivam, please stop. I forget that every single time. Okay. This may continue means skip the value. Yes, it continue means that skip everything that is going to come afterwards. So from this continue statement, if I had stuff up here, it will run, right? But oh no, it's fine, Shivam. It's fine. Yeah, many people do the same thing. It's totally fine. I have done the same thing, in fact. Okay, stuff up here will not run. So after the continue statement, the stuff down here actually, down here will not run. So yeah. Okay, can you repeat break with the nested loop again? Yes, I will come to that, Akash. Okay, so let me make this smaller. This is a bit too big. Okay, now let me add a for loop. Let me say I have another for loop. Int I equal to 0, I less than 10, I plus plus, right? Now I have in another for loop for int j equal to 0, j less than 10, j plus plus. Now what I want to say is if I is equal to j, I want to stop the loop. If I is equal to j, I want to stop the loop. Otherwise, I want to output I plus j, right? So what I'm doing here is, first of all, if I'm going for I equal to 0, loop 10 times. For I equal to 1, loop 10 times. For I equal to 2, loop 10 times, right? And now I'm saying that inside the second loop, if I is equal to j, if I and j are equal, then I'm saying break. Don't go anymore, just break, right? Now I'm saying that see out I plus j otherwise, and I'm outputting it with a space. So basically what's happening is I'm outputting 0 plus 0, 0. Okay, let's ignore the break statement for a moment. 0 plus 0 would be 0, 0 plus 1 would be 1, 2, 3, and so on. And after that, after all of this is done, I want to output a new line, right? So I'm outputting with a space here currently. So after all of this is done, I'll output a new line. And now this will output it in a nice way. So if I run this, let's see what happens. If I run this, you can see that I get for 0, it immediately stops. For 1, it takes 1. And for 2, it takes 2 plus 0, 2 plus 1, 2 plus, okay, let's actually take product. Product would be easier to explain. So here we have 0 into, 0 into 0, 0 into 0, and 0 into, 1 into, okay, what? Okay, so this is, let me just draw it. So we have, initially we have nothing. In the first thing, we have nothing because if I equal to j, we are stopping, right? So we have nothing in the first row. In the second row, we have 0 into 1. And after that, we have 0 into 2, 1 into 2. Then you have 0 into 3, 1 into 3, 2 into 3, and so on, right? So here you can see that we have 0 into 0, 0 into, 0 into 1, 0 into 2, 0 into 1 into 2, 0 into 3, 1 into 3, 2 into 3, 0 into 4, 1 into 4, 2 into 4, 3 into 4, etc. Right? So this is basically like a multiplication table. But yeah, you can see that if you do break, it immediately stops. Right? So after it is done, it stops. And you can see that it only stops from the inner loop. Right? After I'm done with this outer loop, it still continues the I loop. Right? So I keeps continuing. So at the first statement, I immediately break. But I still continues. This after this I break, but we continue. After this it breaks, we continue. After this it breaks, continue, and so on, right? Okay. Now Now, similarly, let's try doing a continuous statement. And here you can see that only when I equal to j, you'll notice no perfect squares. You'll see that 0 into 0 is not printed, 1 into 1 is not printed, 2 into 2 is not printed, 3 into 3 is not printed, etc. Right? So we have 0, 3, 6, 12, 15, 18. There is no 9, right? So we have 2, 0, 2, 6, 8, 10. There's no 4. Similarly, if we have something equal, then it just continues, which means that I just don't execute the output, right? Okay, is this clear to everyone now?
Actually, sir, I am not able to understand this. Like, when will I increment and j increment? Can you show like before if for is not implemented, what will happen? And once the j is in the i's loop, what will happen? So then I'll able to differentiate.
J is in I loop. Sorry, could you repeat that?
J is under i's loop. We have indented that.
This one.
Yes. So both once I is incremented, then it will enter the j's loop.
Yeah.
So actually, I'm not able to differentiate. So without for loop, can you explain once and then show like?
Okay, so basically what's happening here is, let me just output I each time. And if I run this, you'll see that I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So we are incrementing by 1 units up till
1.
Up
yes.
till 9.
Up till 10. Yes. At
Yes.
10 we stop.
Yes.
Okay. Now inside, if I put another loop, what's happening is that for 0, it loops for 10 more times. Right. So what's happening is I is equal to 0. And inside this, we have j equal to 0 to 9. And for I equal to 1, again, after I equal to 1 happens, we are going into the inside loop, right? So we have I equal to 0, and then we start the next for loop, j equal to 0. Then we say j equal to 1, j equal to 2, j equal to 3, because this will keep repeating. So this part will keep repeating until this entire loop stops, right? Does this make sense?
Yes. Yes. Understood.
Yeah. So after
So
I equal to
every one increment of I will have the whole series of j. Then
Exactly.
it will be out of the loop. Then again for the next increment of I, it will enter the j loop.
exactly.
The whole
exactly.
set of j will be completed. Then it will break out of the loop and then it will go on and on.
Yeah, exactly. That's exactly how it works.
So this is loop in loop.
Yes, this is called a nested loop. If you want
Nested
to write the perfect notation, like the actual thing, it's called a nested loop. Okay, fine.
Yes, sir. Perfect.
Yeah. If anyone has any other doubts, please do let me know. Okay, I'll just wait for a second. What's the name of this ID? It's called CLion. I'll just write it here.
Sir, just a doubt.
Yeah, go ahead.
Sir, only break and continue can be used for playing in nested loops. Are there any other syntaxes?
No, basically there's nothing else, unfortunately.
So break and continue.
Yeah, break and continue. Okay, fine. I guess we can move on then, right? If anyone has any doubts, you should let me know, man. Okay. So the next thing we are going to be discussing is arrays. Okay. Now an array is a collection of multiple items of the same data type. And, this is just what it's very simple. What it means is extremely simple. What it means is that basically it's a collection of multiple items. First of all, you have multiple items in here, right? Arrays are generally denoted with these curly braces, by the way. And we have the same data type. So each of these values will have the same data type, which means that if I have 1, 2, 3, 4, this is fine, right? All of them are integers, but I cannot have something like 1 string ABC, character X, and let us say, a Boolean true. Like these are not allowed. Like you cannot do something like this. This won't be allowed, but you can actually take everything of the same data type. If it's all the same data type, then it's totally fine, right? So it's a collection of multiple items of the same data type. So we have the syntax as data type, name, size. Okay, let me just do that. So what I'll do is first say int, because I want to create an int array, and I'll say A. right? A is the name, variable name, and I put these square brackets. So after I put the square brackets, I'll say, well, I want, let's say 7 values, right? So I'll create int A of 7. Okay, now what this means is that we are creating an array of 7 elements, and arrays are first of all ordered. So ordered means that they are in a particular order. If you take the first element, it will always be there, right? So the first element is always 1, the second element is always 2, and so on. So the arrays are ordered. It won't change its order somehow, right? So there are some data types, we'll discuss them in a future class. There are some data types which change their own order by however they decide to, right? They can decide that they want to change the order. But unlike that, arrays cannot change their order unless you manually force it to change the order. So what you can do is say, well, I want to swap 1 and 2, and that is fine. But you cannot change, like the array cannot change the order by itself, right? Okay, so let us say that I'm creating an int array of size 7, right? Okay, now what I can do is say, first of all, okay, now another thing though is that the size of an array cannot be changed. So if I create an array of size 7, I will not be able to change the size to 10, maybe, let's say. I won't be able to reduce the size either. I won't be able to increase the size either. So if I create an array, the array is fixed. Okay, cool. So to use the elements of an array, I can just say A of 0. This will be the first element. A of 0 is the first element, right? Okay, let me actually set the values. Let's say this is equal to 1, 3, 2, 7, 10, 11, and 13, let's say, right? So you can see that my ID is pointing it out, like it is generating it by itself, by the way. See, I am only typing this. I am only typing this entire thing. My ID is automatically generating all these things, right? Don't get confused that 0, 1, those things are generated by my ID. Now, what this is saying is that this is the first value. So 1 is actually, even though it's actually the, index of, even though it's the first element, it gets an index of 0. So this is the 0th element. Now 3, even though it's the second element, it gets an index of 1. 2, even though it's the third element, it gets an index of 2. Now 7 is 4th element, it gets an index of 3. And this is 4, 10 is 4, 11 is 5. And the last element or the 7th element gets the index of 6. Now this is actually called zero-based indexing. This is called zero-based indexing. We also have something called one-based indexing, which we'll not be discussing because it's very rarely used. But what this means is that the indexing is not 0, 1, 2, 3, 4 or something like that. It is instead like 1, it's like 1, 2, 3, 4, 5, 6, and 7. Right. So the only difference is that instead of 0, we have 1, instead of 1, we have 2, and so on. So zero-based indexing is very commonly used compared to one-based indexing. So we'll only be discussing zero-based indexing, but it's not that different. You can figure it out yourself in the future. Okay, so yeah, we have this array. And to get the first element, I'll say A of 0. So let's do cout A of 0. And this will give me the first element, right? And the first element is equal to 1. So if I run this, you can see that I get the output of 1, which is correct. Now let's say I take 3, A of 3. That will be equal to 7, right? So A of 3 will be equal to 7. So if I run this, you can see that I get 7. Now let us say that I take 6. Then I get 30, right? Now, one thing to note is that these array values, A0, A1, etc., these are all just like variables. All of these are just like variables, which means that you can output them. You can say, I want to increase them. You can say A of 6 plus plus. You can see in A of 0. You can do whatever you want, right? You can do whatever you can with a variable to these array values as well. So these array values are basically the same as a variable, except they are stored in a collection, right? So instead of being stored alone, they are stored in a collection. So every single value here, it's like a variable. You can take input, you can add it, you can multiply it, you can perform modulos, you can output it, etc. Right? So everything here is just like an array. Sorry, I mean just like a variable. Okay, cool.
You said you can't change the elements of array, but here in scene you're taking an output.
Oh, okay. So
Input.
okay, actually what I meant was that it doesn't automatically change the order. Like you can take the input and change the order, right? You can change the value if you do it, but Okay, let me give you a small example. There is actually a data type in C++ that does this. If whenever you add a value, let's say I have 1, 4, and 3, 1, 4, and let's say 7. Then if I insert 3 into this, what it does is it automatically sorts it. It automatically inserts 3 and it sorts it, which makes the data type 1347. Now let's say I insert 2. Then it says, okay, I will become 1, 2, 3, 4, 7, right? So this is not an ordered data type because, well, clearly it doesn't have an order, right? Like, I mean, whenever you insert values, it determines the order by itself. We don't get the control, it gets the control, right? But this array is not like that. This array, everything we do is by our own volition. And whatever we do, it's our consequence, right? What we did is only what changes. Increment array, repeat again. Sorry, Aditya Kumar, can you explain what you mean by increment array? Jignesh, yes. A of 6 plus plus will increase the value by 1. Yeah, go ahead, Aditya, sorry.
Okay, sir.
Oh, that's what you meant. Okay, that's what you meant. Yeah, if you take A of 6 plus plus, this will increment the value at the 6th index by 1. So this will become 14. Let us say you had int x equal to 13. If you did x plus plus, x will become 14, right? That's the same thing. If you take A of 6 plus plus, A of 6 will become 14. Now, if I take input, it will change the value. Okay, cool. Now,
Excuse
the
me,
next,
sir.
yeah, go ahead.
Sir, we can perform all the arithmetic operations on these elements.
Yes, we can do any arithmetic operation. For example, I can say A of 6 equal to A of 0 into A of 2 plus A of 1, something like this. And I can take modulo 3, anything like that. Anything can be done.
And now you are redeclaring A of 6. So now
Yes.
at the next step, this A6 value will be taken in consideration.
Yes, the previous value will be changed and the current value will be taken. Again, it's similar to a variable, right? So if you have a variable equal to any value, then you say a variable equal to some other value that will be changed.
So by performing operations, we can just make change to the whole set.
No, not to the whole thing. Only the particular index. You can only change index 13. Right.
Okay.
So when I mean index 6, I mean not index 13.
So
when you
in one statement, we can make change to one index.
Yes, exactly.
So if I have multiple statements, then I can change the whole set of array.
Yeah, if you do A of 0 equal to x, A of 1 equal to y, and so on. Yes, you can change the entire thing.
And the changes in the value above will be taken in consideration in the next steps.
Yes, the latest value will be taken into consideration.
Perfect.
Okay, cool. So the next thing that we can discuss is actually taking input of an array. Now we know how loops work, right? We know how loops work. So let's try taking the input. So what I'll do is say for in I equal to 0, I less than 7, I plus plus, which means that I'm going through each index of the array, right? So I'm going from I equal to 0 to I equal to 6. I'll be stopping at I equal to 7 because at I equal to 7, this statement is false. This condition is false. So I'll stop. Now what I'll do is say C in AI. And this will take input of the value at AI, right? So if I take C in AI, this will take input of the value at AI. And I can do another for loop for int I equal to 0, I less than 7, I plus plus. And I'll do C out AI. And I'll output with a space and I'll see out ended. And if I run this, I will be asked for the input. Let's say I input 1, 2, 3, 4, 5, 4, 3, right? So these are 7 values. And if I output them, you will see that I get the exact same thing, right? So I'll give it some input and I get the same output back. So because I'm taking input of 7 values, I can also say int n, C in n, and I can say int a of n. So this will also work completely fine. So if I do this, this will create an array with n elements.
If we do, sir, in second for loop, if you do plus plus I, then what will happen, sir?
Nothing will happen. Nothing different will happen. Plus plus and I plus plus and plus plus I are basically the same thing, right? So if I do this, this will also work the exact same way. So if I take 1, 2, 3, 4, 5, 4, 3. Oh wait, 1 second. I am taking input of the n as well here. So I need to give 7 here first. And yeah, there you go. You can see that I get the exact same output.
Okay, thank
Yeah. Okay, fine. So these are basically arrays. These are honestly all there is to an array. So yeah. Any other doubts? Anything at all? Please let me know again with a +1 or -1 in the chat. If you have understood, please let me know it's like a +1. Okay, cool. Plus AI, what would happen? Okay, Akash. So if you have plus AI, this will like, it will be pretty weird. I don't recommend doing this, but it won't do anything. Like, it will be the same thing. If I run this, you can see that it's literally just the same thing, right? And if you take A of I plus here, this will not work.
in last class, some instructor said that a pre and post, if we put +I above the
Yeah, that was
before
me
and
actually. I was explaining
Okay.
pre and post.
then
But
it isn't.
yeah,
There is no any problem here if we do plus. Why
here.
it is? Yes, sir. No, sir.
Okay. Oh,
Plus
you mean
I.
up here? Oh, okay.
Yes.
So
sir.
basically, I explained the difference in the last class, I think. So what I said was, if you take I plus and if you say, okay, let me take a different file. Don't ignore my template. Please ignore my template. Don't worry about my template. Yeah, okay. So if you take, let's say, int a equal to 1, b equal to 1, right? Then let's say I see out a plus. Then let's say I see out plus b. Now a plus will be outputting 1, b plus will be outputting 2, because a plus will first output a and then it will increase. So if I output a another time, you will see that this time it is 2. You can see that this time it is 2, right? Similarly here, if you take plus I, well, the thing is no one is there to actually use your value, right? So plus I changes I itself. Like it changes the value of I itself. It doesn't matter if I take I plus or plus I. It's basically the same thing, right? So I'm increasing first, but that doesn't matter because I'm still changing I, right? I is what I need to change. And I have changed. So I change I by taking I plus. It doesn't matter. It's the same thing. Like, for example, it's like saying if I take A plus and plus B, now here the output will be the same, right? So if I output A and if I output B, it's going to be the same thing. Because after I am done with A plus, it doesn't matter. They are both going to have the same result, right? So if I run this, I can see that it has the same result. There you go.
Yes,
But
sir.
if I'm adding during the output, then it matters. If I'm adding after I'm done with the if I'm outputting after I'm done with the addition, then it doesn't matter. So yeah, that's why this doesn't matter. Like you can take plus I or I plus. Either of them is completely fine. Okay, cool. I guess we can move on then. So the next thing that we are going to be discussing, the next thing that we are going to be discussing is functions. So functions are pretty simple. Functions are basically just reusable blocks of code that can be run whenever called. And as I discussed, a block of code is just anything inside a scope, right? Now, functions are basically just reusable blocks of code that can be run whenever it is called, which basically means that if I have a function, let's say I have a function, and to create a function, first of all, you need a return type. I'll explain that in a bit. We have a return type, we have the function name, and we have the parameters. Now, each of the parameters can have a data type. Okay, I'll just do it and then I'll explain, right? So let's say I have int add int a, comma int b. Now I'm returning a plus b. Now what this means is that, first of all, inside this function is called add, right? So this function is called add, and it takes in two values. It takes in a value a and it takes in a value b. Now, if I see out add of 1, 2, then what is going to happen is that, first of all, a will be taken as 1. So you can see that again, my ID is saying that a is 1 and b is 2, right? So a will be taken as 1, b will be taken as 2. And what it does is it says this value, replace it with the returned value. So I'm returning a plus b, right? I'm returning 1 plus 2. That is evaluated as 3. And it says put 3 over here. So see out 3 here, right? So it just says see out 3. Now, the int over here means that the value I'm returning over here, like a plus b. This int says, well, I am actually, int is actually the value that I need to return. So what I cannot do is say this will be returning hello. This will be an error, as you can see, because this is an integer thing. And if I take string, for example, this will work fine. So string works fine, as you can see. Int does not work fine. So if I take a plus b, this will work completely fine. You can see that this outputs 3, right? Similarly, I can have another function, let's say string greet. And let's say I have string name. And what this does is it says cout or return, actually, return hello plus name. Now, what this does is it joins the two strings. So it takes hello name, right? Okay, Alok says, what if we use the same function name again? Okay, now, I really don't want to explain this because it's a bit advanced for now. But if you create another function add with int a, int b, this will not work fine. Even if you put int c, int d, it will not work fine, right? But if you take a different number of parameters, then it will be fine. So if you take a different number of parameters, then it will be fine. But I'd suggest not doing it. Like, unless you know what you're doing, don't do it. So yeah, this is called function overloading. If you want more information regarding this, I'll not be explaining it now, but this is called function overloading. So you can try Googling this and learn it from that. Okay, but don't use this unless you know what you're doing, right? Like, learn about function overloading and then you can do this. Okay, so the next thing that I have is greet. So let's say I have a greet function. Also, Jignesh says, but why function is not written in int main? Like, what do you mean? I'm doing the same thing, right? Like, I have int, I have main. I don't have a return statement. I don't have a return statement because main is an exception. Main is an exception. Main does not need a return statement. So it's an exception, which means that it does not need a return statement. Right? Unlike any other function, every other function, you need to return something. If you don't return something, you'll get an error, right? So if I don't return it here, this will be an error. So if I'm saying int and I don't return anything, that will be an error. But let us say I have string greet and that takes a name and it says hello plus name, right? So let's say I greet. Okay, let's say I'll take the last person in chat, Alok. So if I say greet Alok, it gets hello Alok, right? It says hello Alok. And that is fine. But let us say that I actually want to output it inside this function. So I want to cout hello plus name. And here this will not be like cout doesn't return anything. So I'll just call greet hello. Now, the thing is, you can see that my compiler is telling me this does not return a value. And what should I do? What should I do if my function does not actually return a value? You can use actually a special data type called void. So there's a data type called void, which means that void means you don't return anything at all. You don't return anything at all if you are saying void, right? So void means that you don't return anything. Okay. Jignesh says, so can we write functions inside int main function? No, that is not possible, Jignesh. That is, you cannot write a function inside a function. That is not possible. Okay, again, I will not go into this because there are a lot of things in C++. I cannot cover all of them today, unfortunately. But there's actually a function, like you can write a function and it's called a lambda function. Again, you can try Googling this lambda function in C++, but it is pretty advanced. It's pretty advanced. You can write a function inside another function. I'd honestly not recommend learning this right now because it's completely unnecessary. It will probably be completely unnecessary. But to satisfy your curiosity, if you want, you can write another function inside a function using something called a lambda function. So you can again note this down. So the first thing I had for Alok was that it was function overloading. And now we have a lambda function. So yeah, you can note these two things down. For people who want to satisfy their curiosity, you can go ahead and try Googling this. But yeah, I won't be explaining this today. I'm very sorry. I won't be explaining this today. Okay, cool. So yeah, there you go. So if I take void here, if I do void greet string name, you can see that it gives me hello plus name, right? So it gives me hello plus name. And if I run this again, even without the cout statement inside the main function, you can see that I get hello world. Sorry, not hello world, hello, right? Okay. Yeah, so that's basically how it works. So are functions clear? Are there any doubts regarding functions?
Excuse me, sir.
Yeah, go ahead.
This is regarding in the int main you have written alloc. So this is your compiler which is giving this a name. But how does this know that this is the name which we are declaring?
Okay, sorry. You mean this name
Alloc.
over here?
Yes, alloc. Greet alloc.
Yeah, so what I'm saying is I'm saying greet alloc, and this will go in like this alloc is getting passed as the string name, right?
So whatever we declare here would then go here and as a string name hello.
Yes, name will be equal to alloc. So when I'm running this, alloc will be taken and string name will be alloc.
Okay.
So for example, let's say I take string input name to just to differentiate, and I do C in input name. I'll say greet alloc. Like instead of greet alloc, let's say I do greet input name. Now let's say I take another name. Let's just say Jignesh, right? Now you can see that it gives me hello Jignesh, right? So input name is Jignesh. Input name is given, and it takes it over here, right? So it takes the input name and passes it as a name. So it takes hello plus name, and our name was here Jignesh. Is this clear now?
Yes, sir. Perfect.
Okay, cool. Yeah. Okay, please let me know it's like a +1 or -1 in the chat. Is this clear? Okay, use of line number 4 and 5. 4 and 5. These are like I know. I'm not using them actually. It just adds 2 values. Like if I have add int a, int b, it just adds 2 values. What is specialty of void? So void means that you are not returning anything. But if you take something like a string, then you have to return a string. Otherwise, it will be a compiler error. Like I don't know if it will happen now, but generally it's a compiler error. Yeah, you can see that it's not a compiler error. I mean runtime error. You can see that it basically crashed, right? Yeah, you can see output and it has basically crashed. So if I run this again, you can see it's not working properly. So yeah. So don't do that. You will get an error. Very likely you will get an error. But yeah. Okay, cool.
Sir, yeah, here the code crashed, but it is showing exit with code 1. So what does that 1 signify? Because every time we get a 0.
Yeah, and that is pretty simple actually. So whenever you are exiting with code 1, that code 0, that means that your code ran fine. But if you have any other code, that means that your code has an error, and that 1 or 2 or whatever number it gives you helps you debug the error. So if it is 1, then it is a particular kind of error. If it's 2, then it's another kind of error, right? So I will try Googling this. I'm not sure if it will come up, but I can try. Let us, okay, oh God. What? Okay. Let's say that I want to Google exit code 1 in C++. Okay. Here you can see that, okay. Okay, they're not explaining the error itself, but GFG probably has it. Okay, they're not explaining it properly. But sometimes you can see that over here someone has asked, why is my exit code status 1? And they are saying that this may happen when your program got some undefined behavior, right? So something like that. You'll be able to figure it out. Okay, exit status 1 generally indicates that there has been a runtime error that might be due to some fault due to the programmer, right? Due to the programmer, there's some runtime error. And you can see that here we did some mistake and it gives me a runtime error. So you can debug the issue. There are other kinds of runtime errors. There are many kinds of runtime errors actually. So in all of these cases, like you can just Google them. You can just Google them and you'll be able to figure out what exactly the issue is. So it just helps you debug basically. Okay, cool. Compile time versus runtime error. So compile time is before it even runs, right? Before I am actually running the code, before it asks for input, before it does actually anything useful, it gives me an error, right? For example, if I do something terribly wrong, like I have a syntax error here, I don't have this, I don't have anything proper. So if I run this, you'll see that this will be a compile time error. But runtime error happens once the code has started to run. So once the code has started to run, That's a runtime error. Okay, cool. So yeah, I guess we can move on then. So I'll be going on to the next thing. And the next thing that we are going to be discussing is the range of integer data types. Actually, I should remove the integer here, range of types in general. So yeah. So first of all, for integer, we have 2 to the negative 2 to the power of 31 to 2 to the power of 31 minus 1. And what this means is, let me take int x equal to, okay, first of all, if I have int min, this will be the smallest value possible for an integer. This is inbuilt into C++. You can use this to figure out whatever the value is, right? So I can say int x equal to int min, and then I can say, well, C out x. Okay, actually, let me take int max. Then let me do C out x, and let me run this. You can see that I am getting some value, right? And this value is exactly equal to 2 to the power of 31 minus 1. So let me just prove it to you. Let's just take 2 to the power of 31 minus 1. And you can see that it's 21474 something. And here again, it is 21474 something, right? So yeah, so you can take int x equal to int max, and that will give me the value. Now, let us try taking x plus 1. And if I run this, you'll see that it's pretty wrong, right? Y is the maximum value plus 1 equal to a negative value. That should clearly not be negative, right? Okay, let me also, I'll come to that in a bit. Let me also output int min. So you can see that this is actually equal to int min. Okay, let me actually output int min, and let me output int max, right? Then let me output int max plus 1, and let me output int min minus 1. And if I run this, let's see what happens. You can see that clearly over here, this is the int min value, and int max plus 1 is actually equal to int min. And int max is this value, and int min minus 1 is equal to the same value. Int min minus 1 equal to int max, and int max plus 1 equal to int min. So how does that actually work? Okay, so it's actually pretty simple. So how it works is, if you have 0, initially, let's say you have 0, then you have int min somewhere. You have int min. Okay, 1 second. You have int min over here, let's say. Then you have int max. And these two are these two are very close. So basically, you start at 0, you go to 1, you go to 2, you go to 3, and you keep going on for a very long time, right? So you go to 1, 2, 3, and so on until you come to int max. Then after int max, this is the maximum value possible for an integer. And how C++ has defined numbers is that after int max, you get int max plus 1 will be equal to int min. So then after that, we'll have int min plus 1. Then you'll have int min plus 2, int min plus 3, and so on until we get back to 0, right? So this is the cycle. We start at 0, we go till int max, imx, let's say, for int max. Then I go to imn, which is int min. So plus 1 will be imn. Then I go back to 0. And the cycle keeps repeating, right? So this is basically how this works. So this is actually called an overflow. Whenever you are going from something that you're expecting to something that you're not expecting, because you are cycling through like this, whenever you go from int max to int min or something like that, then that will be called an overflow. So whenever someone says it's an overflow, then you should know that your integer was too small to hold the value that you wanted. Okay, Ankit says we use int max and int min to find the maximum and minimum element. No, okay, yeah, int min is the minimum value possible for integer. Yes, okay. So int min is, yes, it's the minimum element possible for an integer. Int max is the maximum element possible for an integer. You are correct. Okay, similarly, we also have L-long max. Let me just remove this. We have int min, int max. Then we also have L-long min, L-long max. This is long value. So if I run this, you can see that this is much bigger, right? Okay. Ankit says, can you specify why we get runtime error? So that's honestly a very vague question. It's not, it has a multitude of reasons. For example, we did a mistake before, that might give me a runtime error. Let's say I did a division by 0, that will give me a runtime error. Let's say I have an array with 5 elements and I am trying to access the 10th element. This might be a runtime error. If I am trying to access the negative 10th element, that might also be a runtime error, etc. Right? There are many ways you can get runtime errors. So like it's too many to count, unfortunately. Okay, yeah. But you can see that L long min and L long max, they have a much bigger storage value, right? So they have a much bigger storage value over here. Okay, so this is how it works. First of all, okay, Jignesh says with just +1, you are switching from a huge value to a very small negative value. Yes, in fact, you are switching from the largest value to the smallest value, which is pretty ironic, right? When you're trying to increase the largest thing, you fall down to the smallest thing. That's pretty ironic in my opinion. Yeah. Okay. Okay, sorry, I did something weird. Okay, there you go. So here, we should know that integer is actually almost 2 to the power of 31. Like, I mean, it is equal to 2 to the power of 31 basically. And 2 to the power of 31 is a bit higher than 2 into 10 power 9. Okay, let me just write this down. We have 2 to the power of 31, which is just greater, barely greater than 2 into 10 power 9. Similarly, we have 2 to the power of 63, which is for long. For long min and long max, we'd have 2 to the power of 63. So for 2 to the power of 63, this is greater than or equal to 9 into 10 power 18. So 2 power 31 is 2 into 10 power 9. 2 power 63 is 9 into 10 power 18. Okay, there you go. So that is basically int and long. And after that, we also have the third element, actually, which is called long. We just have long. And we have int, long, and long, right? First of all, I'd just like to say that long and int are basically the same. Long is just basically equal to int, unless you're using a 20-year-old computer, in which case I'm very sorry for you. Unless you're using a 20-year-old computer, long is equal to long. They are basically the same thing. They're literally just the same thing, right? So yeah. So don't never use long. This is not true for Java. If you're using Java, then long int is much bigger. Like long int in Java long int is equal to C++ long. But C++ long int is equal to C++ int, right? So int and long are basically the same thing. Okay, cool. Now, the third thing we have here is float. For floating point values, for float, we generally have around 7 digits of precision. For double, we have around 15 digits of precision. And for long double, sometimes we have 18 digits, but it depends a lot on the compiler. So if you try it with a local compiler, you might see that you only have around 15 digits of precision. Like you will have long double will have greater than or equal to precision as a normal double, right? And normal double will be greater than float. It will be at least like greater than or equal to 2 times the number of float. So for example, float, let's say has 7 digits, then double will have around 15 digits. And long double will have greater than or equal to double, which will be around 18 digits. It might depend on your PC to another PC, but in CodeChef, Codeforces, etc., long double is much bigger. Like long double has more precision than normal double. So always use long double if you are using CodeChef, Codeforces, or something like that. Okay, cool. So yeah, that's honestly all there is. But there is one final thing. Let's actually take a float value. Let's say I have float XYZ. Okay, equal to, let us say, a pretty big value. Okay, actually, let me take double. Double XYZ, let's say equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let me output XYZ. Now, the issue with double or any basically floating point data type is that they like to approximate. After some point, they like to approximate. So you can see that this actually doesn't output 1, 2, 3, 4, 5, 6, 7, 8, 9, but it rather outputs 1.23457 e plus 0.8, which basically means that I'm taking 10 power 8 multiplied by this thing that I have over here, right? And that's honestly, let's say that, it is going to give you W8. It's a bit weird and it's going to give you W8. This is called scientific notation. But if you output this when they are expecting an integer, you will get a wrong answer. So whenever you are outputting a double value, please make sure to add like int in parentheses next to that double value so that you are converting it to an integer. So I'm taking in XYZ. which is converting XYZ to an integer, right? So if I run this, now it will work fine. You can see that now it works fine, right? So it has everything that it needs, but it just outputs it in a scientific notation because that's how float is implemented. So whenever you are outputting a float, please make sure to add int before that so that you don't get a WA. Otherwise, you will get a WA. Like if you have long, big values, then you will get WA. Okay, fine. So is everything so far clear? Please let me know it like again a +1 or -1 in the chat.
Double XYZ, why we not used in decimal?
We can do that. If you want, you can do that. If I use that though, now when I convert it to an integer, this part will go away. Let me show you. If I do this, you can see that it goes away. And if I use normal XYZ, then the issue is that you won't be able to see that decimal point anyway. But let me take a small value. Now it will work fine.
Excuse me, but the purpose of float and double is for the numbers which have decimal points, right?
Yeah.
The decimal numbers.
Yeah.
Okay. And do we need to use them in codes, or we can, or not? I mean, are they frequently used in codes?
They are very infrequent because most competitive programming problems realize that floats suck because,
Okay.
you know, C++ and stuff, everything has a basic flaw, right? Everything has a very basic flaw, which is, for example, let's say I want to take 1/3. Can you tell me the exact value?
Yeah, it's actually recurring.
It's
Yeah.
not possible, right? But the thing is, we are doing this in base 10. When we are doing this in base 10, we have some collisions. But similarly, when we are doing division in base 2, similarly, many things cannot be represented. Many things cannot be represented in binary.
Okay.
So that is why we get a lot of floating point errors. Like you'll have seen many memes, right? Like taking something like 3/5 gives you some like weird errors.
Yeah.
And the reason is because, again, binary is pretty bad. So most problems realize this and don't give you a question like that. But some problems might do that. And if they do that, you can use a long double and you'll generally be fine. Like they won't force you to know way too much of this stuff.
Okay. Okay. Yeah.
Yeah.
Thanks.
Yeah, no problem. Okay, Arun is saying, please explain floor and seal. They're very simple. Floor is a function. I need to include math for that though. I need to include math.h and I can use floor. So basically, okay, what this does is it, decreases the value. Let's say I have ABC equal to 0.9934 or something like this. If I floor XYZ and if I floor ABC, you'll basically see that it becomes from 12.1234, it becomes more 12, and 12.999, it becomes 12 again, right? Similarly, if I take seal, it will go to the next greater integer. So it's going to 12. Now it's going to 13. So seal is the next larger integer and floor is the previous smaller integer. Right, that's basically the thing. That's it. That's honestly all there is. But if you take an integer directly, then it won't do anything at all. So you can see that it just gives me 12 again. That's honestly all there is. Okay, fine. So yeah, round. Okay, round gets, round, right? Everyone knows round. If you have, everyone knows round, obviously. Okay, Arun says negative number floor. Okay, that's actually a good question. So what happens if you take a floor of a negative number? Let's see what happens. Okay, if I run this, you can see that I actually get negative 13, right? And it makes sense. If you look at it, it makes sense, right? So floor goes to the smaller value. So if I have 12.x, I go to 12, right? If I have 1.x, I go to 1. If I have 0.x, I go to 0. Then if I have negative 1.x, then, well, where should I go? Well, I should go to, okay. If I have negative 1.x, see, I already am at a lesser value, right? Like, so I need to get to a value that's lesser than me. So if I have, for example, 0.1, let's say, then this will go to 0. If I have negative 0.1, that will go to negative 1, right? Like, okay, let me draw this properly. If you have 2.1, we are going to 2. If you have 1.1, we are going to 1. If you have 0.1, we are going to 0. If you have negative 0.1, then you are obviously supposed to go to negative 1, right? So you are going to the smaller value, the previous smaller value. Similarly, if I take negative 1.1, I go to negative 2. And the same applies for seal. So seal of 2.1 would be equal to 3. 1.1, it will be equal to 2. 0.1, it will be equal to 1. Negative 0.1, it will be equal to 0. And this will be equal to negative 1. And this will be equal to negative 2, and so on, right? So this is how it works. Okay, yeah. Okay, fine. I guess we can continue then, right? Is everything clear? Any doubts so far? Okay, fine. I guess we can move on then. So the next thing that we are going to be discussing is namespaces. So basically a namespace, okay, Shivam, I'll briefly explain that. Basically, if you have a long, like Shivam is asking what 1LL means. So let's say you have a long value and let's say you have X, right? So something like this. Then you know that if you have X equal to 1, that is long. But let's say you want a long value directly. In that case, you use 1LL. That's it. If you use 1LL, that's just saying to the compiler that this 1 is a long value. So yeah, I won't be going into much detail. You will not use it much, so you don't have to worry about that. Okay, so the next thing I'm going to be explaining are namespaces. So namespaces are actually pretty simple. And what a namespace means is that, it is just a scope, right? Last time we discussed the scope. A scope is everything between a curly brace. And it's just a scope of the program that stores various useful functions and variables. So for example, we have a namespace here called std. And what this means is that this std is just another namespace, right? So std is a namespace. And from std, we are using multiple things. If I remove this, for example, if I cout 1, 2, 3, you will see that this does not work. This will give me an error. But if I use std : cout, and if I use std : endl, this will work fine, right? But this gets tedious very quickly. This gets tedious very quickly. And that is why we have decided to do something called using namespace std. And what this does is it just allows you to never have to write std : at all, right? You don't have to write std : at all. And you just can directly use whatever std has. So that is all there is to a namespace, honestly. But if you want, you can use a scope resolution operator like : in order to avoid that. Like, if you don't want to using namespace std, you can do so by using std : cout and std : endl. So this is a scope resolution operator. This is the scope resolution operator, and this is the namespace. Now, again, if you want to output another line, you have to do something like this again. You cannot remove it. If you remove it, you will get an error. Okay. Yeah. So the reason we have namespaces is actually to avoid conflicting names, which basically means that let's say you have std, right? So std, let's say we have std and we have using namespace std. Now let's say we have another namespace. Let's just say it's called DTS, right? So these two are just two random namespaces, and the reason the second one doesn't exist. It's hypothetical. The reason we use namespaces is just so that if you do something like cout, std : cout, some value, then let's say DTS also has cout. So std has cout, DTS also has cout. Then in this case, if you use normal cout, the issue is the compiler won't know which cout you are referring to, right? Are you referring to std or are you referring to DTS? Because both of them have cout, right? So that's why we have namespaces. So namespaces are generally there. So that if you have something like this, you can use std : cout, and you can use DTS : cout, and they'll be different things, right? So there'll be different things, and that's why we have namespaces. But generally in competitive programming, you're not going to be using that at all. So you don't have to worry too much about that at all, because you won't be using that. Like, you only have one namespace, which is std. You'll only be using std. Okay, fine. So yeah, I guess we can move on to the next thing then. Okay. RS is known. So namespace is the data type of a library which contains many functions. Yes, something like that. So it is in fact like it's like a collection of variables and stuff. And if you do using namespace std or using namespace whatever name that is, you will be able to use all the functions. Okay, cool. So the next thing that we have is header files. Now header files, unlike namespaces are a piece of code basically, but header files are a bit different. Header files are just a file. It is literally just a file. If I go to IOStream, for example, you can see that I'm at a file, right? So IOStream at the top over here, that is a file. So basically headers also contain variables, functions, etc. Except that they are generally much bigger. They are like namespaces, but they are much bigger. And you will be able to like include a header file, and you will be able to use the values of the header file. And you cannot use something from a header file if you don't include it. Like if I have something like this, I won't be able to use cout at all if I don't include #include IOString. So unless I do #include IOString, I won't be able to use cout at all, right? If I don't do #include IOString, I won't be able to use cout at all. So yeah, header files also store variables, functions, etc. Except they are generally much bigger. Now there are two kinds of header files. There is something called a pre-existing header file, and there's also user-defined header file. Generally, you don't use user-defined header files. You don't have to worry about that for now. But we also have pre-existing header files, which is what everything is, like IOStream, string, anything, right? Jignesh says header file is the one which holds STL. Yes, header files do store STL. Like you can do #include vector, #include map, #include unordered map, anything like that. All of the things from STL.
Is CMath header file?
CMap, sorry.
Math, you included in some
Yes.
letter.
Yeah, CMath is also a header file. Math.h is also a header file. Okay, cool. So yeah, the syntax is again very simple. You just do #include file name, and that's it. Can we use bit/std++? Well, I'm glad you asked, because that's literally in the next slide. So yeah, we can in fact do that. I'll come to that. Okay, but normal header files, namespaces, everything is clear, right? Like if anyone has any doubts, please let me know, by the way. Okay, I'll just assume no one has any doubts. But again, if you do, please let me know in the chat. Also, you can just unmute and let me know. Okay, fine. So the next thing that we are going to be discussing, okay, Jignesh says, how can we know what STL is included in what? Well, that is a good question. You have to remember all of it, or you have to do the thing that I'm going to say right now. Okay. You don't think too much about that, because I'll be explaining how you can avoid all of that. Okay. We have a header file for competitive programming. Like Jignesh said, how can we know which header file has what? And like, how can we know which function is contained in which header file, right? So like, for example, let's say I want to do a math function, then it is in which header file? I can't know, right? I need to look up the CPP reference, and I need to go through documentation in order to figure that out. Well, for competitive programming, we have a solution, and the solution is just to do #include bits/stdc++.h. So this is the thing. We have #include bits/stdc++.h. And what this is saying is pretty simple. Well, this is saying, if I go inside this code, you'll see that it's just literally including everything, right? It's literally just doing #include every single thing. So you can use any function from whichever header file you have. So for example, I can use a function from math.h without having to import math.h, without having to include math.h. I can use a vector without having to include a vector. I can use a map without having to include a map, right? So I can just include whatever I want by just doing bit/stdc++.h, and that's it. It's literally that simple. Now let me just do using namespace std. And if I do cout123, if I run this will work fine. I am not using IOStream, by the way. Now, if I want to create a vector, I can do that as well. Yeah, Jignesh, it is like a super header file. It contains literally everything. So yeah, you can see that without having to include a vector, I can use a vector. I can without including a map, I can use a map, right? I can do map intent, and I can use that. That's it, right? So yeah, that's basically just that's one of the best things to exist, because you don't have to remember everything, right? You don't have to remember everything, and you can just use this one thing, and you'll be able to code whatever you want. Now, there are again pros and cons. There are some cons, and the con is that first of all, the pro is that again it includes everything, and you don't have to worry about which header file includes which, and you can just save time during the contest because you'll just include everything. You'll just be including everything, so you'll be saving time, right? But there are cons, and the cons is that it doesn't it increases compile time. It increases compile time, which means that actually, let me explain. So when I click this button, keep a mental count of how much time it takes for the code to end, right? So for this process finish with exit code 0 to come up, just keep a mental note of how much time comes, like how much time it takes. Okay, let me run it. You can see that it's building, and then it stops, right? It says process finished with exit code 0. Now, let me do just IOString. Let me just do IOString. And if I run this now, you can see that it's instantaneously done. If I just run this, you can see that it is finishing immediately, right? If I just run this, it's literally instant. And the reason for that is that bit/std C++, since it's including many things, it needs more time to compile. But honestly, for us, it doesn't matter, right? So the compile time and run time are very different. So whenever you have some code, over here, let's say, then you are taking this code and you're compiling this, right? So the thing is compiled into something that the machine can read. So it is compiled into something the machine can read. And so it becomes, well, a machine code. So it becomes from a code, it becomes a byte code. So this is called a byte code. And the process of converting it to a byte code takes a bit of time. But after that, running the byte code, this output part, this also takes time, right? So this part over here takes time, and this part over here also takes time. But the thing is, it doesn't really matter for us because no online judge like Codeforces, CodeChef, AtCoder, etc., do not care about the compile time at all. They do not care about the compile time at all. And they only care about the runtime. And the runtime is the it's the amount of time it takes to output something, right? So they only care about the runtime. They don't care about the output, right? Okay. Jigdesh says, can you show how we can get a read documentation of header file? Okay. So what you can do is actually go to a website called DevDocs. There's a website called devdocs.io. And in this website, you can just click C++. Here you can find C++ and click it. And if you search something like IOStream, you can see that it comes up. If you double click IOStream, you'll see that it tells you what are all the values like C in, C out, CR, CLog, etc. Right. So there are a bunch of different things. So that's how you can do that. So this is called DevDocs. I'll just share this in the chat. Yeah, you can take a look. Okay, fine. So yeah. So this is basically the pros and cons. And the final thing is that this doesn't work with any compiler other than GNU C++, which means that if you are using a MacBook, it won't work for you. For example, if you have something like CLang or Clang, it won't work for you. And if you have MSVC, it won't work for you. So unless you have anything, unless you have GNU C++, nothing else will work. Like nothing other than GNU C++ will work for you. Okay. So is everything so far fine? Everything is clear, right? Any doubts at all? Okay, please let me know it's like a +1 or -1 in the chat. Okay, I'll just wait for a few minutes. I'll just go get a glass of water. So if anyone has any doubts, you should let me know right now. Okay, fine. I guess we can continue then. So yeah, let's move on to FastIO. Okay, so I did say that I'll be showing some tricks and stuff. So we'll be discussing FastIO now. Okay, so basically FastIO, as the name suggests, makes your input and output faster, right? And I'll be going over this a bit fast, by the way. I'll be going over this quickly because, well, we are running out of time. We are already out of 1 hour and 30 minutes. But I do have a video here. This is my video, in fact. I have made a full detailed video on FastIO. I'll send this in the chat. You can take a look at that, right? Like if this is not clear, if my current explanation is not clear, I have made a video covering everything, like when you should use it, when you should not use it, and what are the pros, what are the cons. I have discussed every single like aspect of it, but I'll cover that quickly right now. Okay, so first of all, we have this iOS : sync with stdio false, and if I include this statement, and let us say actually without this statement, first of all, not use this statement, then let's say I do cout 1, right, and then I do printf. If you don't know what printf is, don't worry, like you don't have to worry too much about that. But let's just say I have cout and printf, both of them just print a value, right? So cout and printf both print a value, and let's say I have cout 3 and printf 4. Now if I run this, you would expect it to output 1, 2, 3, 4, and that's exactly what happens, right? So if I run this, you can see that I get 1, 2, 3, 4, which is what I'm expecting. But if I add this statement and if I run this, okay, actually instead of endl, I'll use \n. I'll explain why later. Printf working in C++, yes, C++ is backward compatible, which means that C code works in C++. C code works completely fine in C++. But yeah, you can see that if I add this statement and if I use \n, you will see that, well, it's actually wrong, right? So it's giving me 2413. And yes, Jignesh, FastIO is for saving runtime. It's not for compile time, it's for runtime. So that is why it's very popular. It makes your code much, much faster when there's a lot of input. Okay. So yeah, we have cout 1, printf 2, cout 3, and printf 4, but this is actually outputting 2413, right? So what this statement did is it removes the sync between printf and cout. Now we have the next statement, cin.tie null. So if I go to the cin.tie null statement, and if I output this, if I output, please enter a value, something like this. Please enter a value. Please enter a value, and let's say I also do int x cnx, right? Now let me uncomment this. Let me say please enter another value, and let me do int y cin y. Then I output x plus y. Now if I run this, it says please enter a value. Let me just output 5. Please enter another value. Let me just input 7, and it's going to give me 12. Right, 12 is the output, which is what I'm expecting. So it says please enter value 5. Please enter another value 7. And finally, it's giving me 12. So let me see out your result is 12, right? So your result is x plus y. So yeah, this works completely as expected. Sorry, 1 second. Oh, what? Okay. Yeah. Okay, I give 5, let's say I give 7, and your result is 12. But let us actually include the statement. Let's actually include the statement and let's see what happens then. So if I run this, notice that it's actually not outputting anything. It's actually not outputting anything, right? And let's say I input 5. It's still not outputting anything. Let's say I enter 7. Now it says, please enter a value, please enter another value, your result is 12. All in the same line. And the reason is because if you're using FastIO, then it removes the synchronization between input and output. There's no sync between input and output. And all the input is taken first before all the output, right? All the output is given after the program ends. So it is given actually after the program ends, or when I use endl. So I will explain this out. First of all, let me just replace this with \n. So if I enter 5.7, you can see that again it's the same thing. But \n is actually a special character. Like \n and endl are a bit different in the fact that endl actually clears, like flushes, it is called flush. Endl flushes a buffer. So what this means is that buffer is first of all a temporary storage area, right? So if you are printing something, then it is temporarily stored in the buffer until you're actually printing it, right? So you are actually, unless you're actually printing it, it will keep, it will be stored in the buffer. So here, when I output this, since the tie is removed, endl is storing this in the buffer. Now, what happens though is that when I use endl, it flushes the buffer. If I cout endl here, for example, and if I do cout endl here, okay, let me explain without endl first. Let me comment this out, show you one final demonstration. Let me input 5 and 7. Oh, okay, I get 76, but whatever. So your result is 81. But now let me add the endl. Let me add the first endl, but let me not add the second endl. right? So if I run this, you can see that it says please enter value now. But if I enter 5, it doesn't say please enter another value though, right? It doesn't say please enter another value, but when I enter 7, you can see that it says please enter another value and your result is 12. But if I comment this as well, and if I run this, uncomment this. So I am outputting endl after each output statement. Says please enter value, I'll enter 5. Please enter another value, I'll enter 7. And now the result is 12. Basically, what endl does is if you have not printed anything so far, it immediately prints it. It immediately prints whatever you have not printed so far. So that's why endl is used, right? But that is the exact reason why endl is extremely slow. Endl is extremely slow because it clears the buffer or the temporary storage each time, right? And whenever you're clearing the temporary storage, it will take some time. So never use endl when you are using FastIO. So whenever you are using FastIO, use \n rather than endl because \n is much faster. Okay, but yeah. So if you first of all, the first statement removes the sync between cout and printf. The second statement removes the sync between cout and cin, and endl forces the input buffer to flush. Okay, Jignesh says then you must know the exact number of inputs to be given. Yes, you must basically know the exact number of inputs to be given, but that doesn't matter for us, right? Why does that matter for us? Because in every problem, they tell us the exact input format and they tell us how we need to take input and stuff, right? So if you know how to take the input, you'll know the number of inputs to be given, right? It will always be the same number of inputs. Like, if you have 5 elements and then you have 5 array inputs, then in total, you'll take an input of the number of elements, which is 5. Like a number of elements will be 1 input and the elements itself will be 5 inputs. In total, you take 6 inputs, right? For example, what I'm trying to say is, let's say I do int n cn, then I have an array of n values. And what I'm doing is taking input of this, right? I'm taking input of all these values. So if I run this, I know that I need to give, if I give 5, I know that I need to give 5 values. And so you can see that it stops, right? So I know the number of input. So basically, if you know the input format, then you know the number of inputs as well, right? Technically. So yeah, you don't have to worry about that either. \n runtime versus direct FastIO without endl or \n. Okay, so if you have \n plus FastIO, it will be fast. If you use endl plus FastIO, like if you use endl plus FastIO, then this is just going to be as fast as no FastIO. So this is basically the same speed as no FastIO. So if you had no FastIO at all, this will be the same speed. So don't use endl. Prefer not using endl. Okay, Surendra says will be useful if there's no combination of cin and cout. Yes, exactly. So if you are building something for your local thing, like let's say you are building a small calculator, a small game or something like that, never use FastIO. Don't use FastIO. But if you are doing something for CP, then you can use FastIO. But there are exceptions. There are problems called interactive problems, in which case you will actually have to remove this FastIO. But again, please watch this video. I have explained literally everything there. So yeah, I'll send this in the chat. If you have any doubts, please ask. But watch this video. It has basically everything covered, like any doubt covered. So yeah. Okay, Jignesh, I didn't understand your question. \n runtime versus direct FastIO without endl or \n runtime. Okay, that's
So
that's
the first case where we did not use endl or \n and directly we are entering the inputs and then all the 3 statements came together. So I'm asking \n versus that.
Okay, \n is not slow at all. \n is the same. It takes the same amount of time as just outputting a single character. If I'm outputting A, or if I'm outputting XYZ, that will take the same amount of time to output \n.
So \n is the fastest.
Yes, \n is the fastest.
And if we don't use \n then directly, like we were not able to see that statement directly, we are giving the inputs.
That will basically take the same amount of time. I mean, what I'm trying to say is outputting \n won't slow your code at all.
Okay.
But if you use endl, that will be much slower. Endl will be much slower.
So endl will increase the runtime.
Yes, endl will increase the runtime. \n will not change the runtime. Like if you use FastIO plus \n, that will not change the runtime. Like, okay, FastIO plus \n, it has the same amount of time as FastIO. Now endl plus FastIO has the same amount of time as no fast failure. So yeah,
So like sir, you in Endel you said that it is clearing the buffer. So in backslash and what is happening in the backend?
it is not clearing the buffer. It just goes to the next line. Like it just puts the next line, new line to the buffer.
So it is just switching.
Yeah. So let's say that the buffer is like this. Buffer has cout, like it has couted some value here, right? Now I'm doing endl. Now what will happen is that endl will clear all of this and it will put all of that outside, and then it will clear the buffer, right? So the buffer will be cleared. But if I use backslash n, all it does is it goes to the next line here, and then it goes to the next line, and then it goes to the next line. The buffer is not cleared. The buffer stays the same. In fact, you're adding to the buffer by going to the next line. So after you do backslash n, so let me just write backslash n here. This is backslash n, this is backslash n, and this is backslash n.
So sir, adding to the same buffer will not make any difference, no?
No, adding to the same buffer will not increase the speed. Like, I mean, it will not, I mean, increase the runtime.
Yes.
Okay, fine. So yeah, so that is basically faster. Okay, so the next thing I'm going to be discussing, by the way, is this template over here. This is my template. So you can see my template over here. And I promise that you'll be able to understand everything by the end of the class. And I'm pretty sure everyone can. Okay, so the first thing we have is hash include with slash std_c++.h. And then we have using namespace std. Then after that, we have hash define endl as backslash n. And then we have hash define int as long, right? So yeah, first of all, the reason I'm doing hash define endl as backslash n is because I just have a practice of just writing cout 1, 2, 3 endl, right? So I like doing this, and every time, you know, it becomes slow, right? As I discussed, endl becomes slow. So what happens if I do hash define endl backslash n is that whenever I type endl, it's just replaced with backslash n instead. So yeah, whenever I am using backslash n, sorry, when I'm using endl, I'm actually using backslash n. I'm never using endl, never using actual endl, right? So yeah, so this is the first statement. So I'm never using actual endl. So yeah, that's why it's there. Then after that, we have hash define int long. And the reason I'm doing this is because, well, I don't want to overflow. For example, if I take int a equal to, let's say I have int a c in a, and I have int b c in d. Now, let's say the problem says a comma b is less than or equal to 1e9 or 10 power 9, right? But I have to output a times b. Then in this case, if I run this, and let's say I give it the input of 10 power 9 and 10 power 9, then, you know, I might be expecting, I might do a mistake and say that, well, this value, it's actually going to be like, you know, since both of these values are less than or equal to 10 power 9, the output will also be less than or equal to 10 power 9, right? I might think that, but that's not at all true. If I enter a value, and if I enter another value, you can see that this will be up to 10 power 18, right? So this product is up to 10 power 18. So if I do use hash define int long, this helps a lot. But if I don't have it, so if I don't have it, and if I run this, you can see that this actually overflows, right? When I do this, it overflows. So if whenever I have hash define int long, it helps a lot because I'll never accidentally overflow. So that's actually why I have hash define int long. Okay, cool. Now, after that, we have constant mod equal to 1e9 plus 7. So constant mod equal to 1e9 plus 7 basically means, like, you know, in a lot of different problems, you might have seen it, but you might also see it in the future. But a lot of problems say you want to take 10 power 9 plus 7 as modulo. So you want to take the output modulo 10 power 9 plus 7, right? So it's a very common modulo number. So I just have that as a constant because it just, you know, whenever I want to take modulo, I can just type modulo mod, right? So I'll be able to do this. So that's why I have this constant. And the final constant that I have here is infinity. So this is basically like infinity. And what this is just L long max divided by 2. Now this thing that I did here, it's just a bitwise operator. That's just the same as dividing by 2. Okay, Srihari, do you have something to say?
Yeah, like the two constants that you have at mod and inf.
Oh, okay. So infinity I'll explain. Yeah,
these are constants. Like we are entering the program. Like, so in which problem we enter, how will we get to know that? Like when to use this?
So basically in a lot of problems, like if you take a number theory problem, let me just search code forces. Let me just go to problem set and I'll just open a random problem. I'll not be solving this, by the way. That's not what I'm saying. Let's just say that I choose a combinatorics problem, apply. Just take one problem. Yeah, you can see that it says printed modulo 10 power 9 plus 7, right? So in this case, I'll just say, well, I can use modulo. I'll just use the output modulo, whatever modulo that I want, right? Modulo mod. So yeah, this is where I will use modulo mod, and infinity I will use whenever I want to, like, let's say, take whenever I want to compare with some large value, I will take infinity. So because infinity is basically equal to 4 into 10 power 18 here, 4 into 10 power 18. And in most problems, you will never cross 1 into 10 power 18. In most problems, you will never be asked to cross 1 into 10 power 18. So 4 into 10 power 18 is pretty much unreachable, right? So since it's pretty much unreachable, I just have infinity as a value. Like, I can just compare if any number in any number xyz less than infinity, this will always be lesser. This will always be true. Okay. You will actually find the use case of this a lot in problems where you have to deal with minimum and maximum. Let us say that you want to find the minimum of an array. Then you can set the initial value as infinity so that whichever value you take will be smaller, right? Like whichever value you take next will be smaller. So that's why you have infinity. Okay. Yeah. So these are my constants. And here I have signed main. You might wonder why I have signed main. And the reason is that if I actually have int main, then what happens is that since I have done hash define int long long, this int gets replaced, right? So it gets replaced to long long here. So it takes long long main, and long long is not allowed. You can see that here it says main must return int, but luckily signed main is the same as signed is the same as int. So signed and int are literally the same thing. So I can use signed main instead, and that's just what I do. And after that, I have my fast IO. And finally, I also have this test case thing. Like, I'm just taking input of the number of test cases. So you can see in many problems, you have 5 test cases or something like that. So I'm taking in TC, C in TC. And while TC minus minus, this repeats for TC number of times. And yeah, this is basically my template. That's honestly all there is.
Can you please explain signed main part again?
Yeah, sure. So when I use int main, what happens is that this int gets replaced. So since I have done hash define int long long, int gets replaced with long long, right? So it gets replaced with long long, and main does not like it when it returns anything except int. Anything except int means that the main function is not correct. So I have to return int. But it turns out that signed int is the same as int. And when you have signed int or something like that, you can shorten it to signed. For example, if you have long long int, you can just shorten that to long long, right? You can just shorten that to long long. Similarly, if I have signed int, I can just shorten that to like signed, right? And signed int and int are basically the same thing. So I can just say signed over here, signed main, and this will be the same as int main.
Okay, yeah, got it. Thanks.
Yeah. Please share your template here. Okay, actually, I'll share it in Discord in a bit. Right after the class ends, I'll share it in Discord. That's a good point, though. Thank you for reminding me. I didn't share it in the previous class either. So, yeah, I will do that. Okay. Yeah. Okay, I'll wait for a few minutes. If anyone has any doubts, please do let me know. But this is basically the end of the session. So I have some resources here. So you can go through these videos for the resources. Do you have any video explaining setup for CP? Unfortunately, no. I'm very inactive in YouTube because I have my exam soon. So yeah, I'm not posting many videos, unfortunately.
Can you share that PPT as well?
Yeah, I will share the PPT very soon. After the class ends, I'll share the PPT.
So the two constants that you have mod and inf, like these are the like irrespective of whether we use it or not, you use it as a template on your program, whether you use it in the program or not, right?
Yes, exactly.
Okay. Because last week we had a problem and I did not even know what this mod was.
Oh, okay.
So, and we couldn't solve it. And then when I entered a query, they told us there is something called mod and inf. So that's why
Oh, okay, okay.
there was no test case was not passing, and then we got to know about this. That's why it was clear.
I see. Yeah. So
Thanks.
yes. Yeah, no problem. Yeah, Jignesh, I can't help again. As I mentioned, I have my exams very soon. So I can't help for like, the next 12 days actually. But yeah, you can, like Arun Kumar is saying, like you can watch multiple videos. You can there are many resources online already. So you can go through them. Like you can go through them once. And then if you still have any doubts, ask in TLE and you can also ping me. Can you use this template from now onwards? Yes, I cannot put a copyright on this, don't worry. So Lakshya says, isn't this test case loop going to be infinite? No, I'm taking the input, right? I'm taking the input, I'm doing C and TC, and then I'm doing TC minus minus. So what happens is when I'm doing while TC minus minus, first we have TC, let's say, is equal to 3, right? Then TC minus minus will check whether 3 is true or not. 3 is in fact true, right? Because everything except 0 is true. So 3 is true. So TC will become 2, right? And then it will check whether 2 is true. And then TC will become 1. And after that, it will check 1 is true. Then TC will become 0. Then for 0, it will say TC is false, right? So 0 is false. TC will become -1. But since it is false, it will immediately stop. So at the end, TC will be equal to -1. Here it will be equal to -1, but it doesn't matter for us, right? It doesn't matter for us because, well, the loop already repeated 3 times. So I wanted TC to repeat 3 times. I started at TC equal to 3 and it did its job, right? So it won't be infinite. Which exam? It's my boards actually. 12 boards.
So at TC -1, the loop stops automatically.
Yeah, TC equal to, like, it stops at TC equal to 0. But when we are checking for TC equal to 0, we already did minus, right? So it decreases to -1. That's fine.
Okay.
Yes, Arun, I am in 12th standard. Srihari says, good luck, bro. Thank you very much, Srihari. Okay, Jignesh says, so do we have sessions every Saturday as well? So the next Saturday, there probably won't be a session. Like it might be there, it might not be there, because I have my exams again in 3 days. In fact, I need to travel and stuff. And after that, I also need to, prepare. So yeah, there probably will not be a session, but yeah. Thank you, Arun. Yeah, okay. Okay, I'll just wait for a few minutes. If anyone has any doubts or anything like general to ask, you can let me know. So Lakshya, basically these constants are just, you don't have to use them. You don't have to use these constants, but if I'm using the constant, then it's fine, right? Like, for example, let's just say that I see out like something and I need to take modulo, right? Then in that case, well, I can just use a modulo, right? I'm not saying that I need to use these constants. I don't need these constants. But if I have to, I can use it. Like in some problem, I might need to use infinity. I will use infinity in that case, right? So yeah. Thank you very much, Kristika. Okay, Jignesh says, if there's some session, please keep us informed. Yes, I will inform at least 24 hours before the session. And, if I don't inform within 24 hours, then there will be no session. So, yeah. Timing of DR class? Okay, I don't know, honestly. Like, you should probably look in the server. Okay, again, I'll be waiting for a few minutes. If anyone has any doubts, please do let me know right now. LeetCode rating. Okay, I have participated in a grand total of 3 contests on LeetCode, and that too was like a few years ago. So it is 1810 or something. So yeah. No, so much. I'm not doing JE at all. Like I am not writing JE. I'm actually looking for entry into like some colleges like IIIT Hyderabad or IIT Gandhinagar via Olympiads. So I'm actually a silver medalist in an Olympiad. And I also qualified till the second to last level, like IOITC. It's called IOITC. So I have qualified till that. Thanks, Jignesh, by the way. And yeah. Will you teach left and right shift operator? Yes, Arun Kumar. That will be explained during the bitwise operators class. But if you want, you can Google it. Like it's not very hard. If you just want to know about one operator, then you should probably just Google it and learn it yourself, But yeah, but I will teach it. I will be teaching it, but you can also Google it on your own if you want. Thank you, Arre. Does rating on Codeforces increase by only giving contest or by doing question also? It only increases by contest. There is nothing associated for solving problems. We have access to 1.1 TLE sessions as well. Will watching those recording be beneficial? So honestly, I just suggest that you don't have to watch it, like you won't miss out much. But if you want, you can watch it on like 2x speed and you can skip it, like spend like 10 minutes in total and you can watch the entire thing. Honestly, there'll be nothing special though. Like there'll be nothing new. Okay, fine. Yeah, everyone is free to leave, by the way. Unless you have any doubts, you are free to leave. Okay, I'll wait till 8:15 and then we'll be ending the session. Yeah, bye so much. How do you maintain coding and studies? I am doing a pretty bad job at it. Like I have basically quit coding right now. Like I only take classes for TLE and stuff. Oh, yeah, I should share the feedback link. Yes. Thank you for reminding me. I'll share the feedback link here. Please do fill the feedback form, by the way, everyone. I have shared this in the chat. Please do fill it. It will be very helpful. Okay. I guess no one has any doubts then. So yeah, I guess we'll be ending the session here then. So if anyone has any doubts, you can also ask me on Discord, by the way. You can ask me anytime on Discord. So yeah. Thank you, Lakshya. And yeah, bye. Okay. Yeah, that will be the end of today's session, guys. And yeah, I'll see you again next time. Bye.